Good afternoon, everyone. And thank you, Mr. Kisan, for inviting me for this presentation. Before I start, Kisan had one query, maybe that has come from you guys. That, sir, can I do project under you in your lab? That you asked. So regarding that, I want to say all of you that if you want to do project work at my lab or in any DRDO lab, what you have to do, you get one letter from your HOD and forward it to LRD. You can go directly there. I will help you. You can take my number and or you can acronyms here in the acronyms. So LRD is basically developing radars. Radars you guys may be knowing a little bit idea you may be having. It detects enemy aircrafts and vans and also controls the weapons to target that. So it is one of the lab of DRDO situated at Bangalore under electronic cluster lab. And latest radar what we have developed is known as medium power transportable radar. It has a range of 400 kilometers. It can detect and send the signal to the target. This radar is a multifunction radar. It can do dedicated tracking. It can do dedicated surveillance. It can do surveillance while tracking also. Then it is featured with ECCM feature that is called electronic countermeasure features also. So in terms of radar, India is self-reliable. We have developed so many technology. We are at the par of the world. Still, some of the radar we are importing, like long-range radar. But at the same time, we are exporting also some of the radar to our neighboring country, Asian countries. Asian countries, Thailand, Cambodia, those are smaller countries. So what our old technology radars, those are having low range, like 150 kilometer, 200 kilometer. That is sufficient for those countries. So they are taking help from us, and we are going for longer range, like 2,000 kilometer, 1,500 kilometer range radars. So those radars we are now developing. Not only that, we are now presently space-based radars are also coming. That is something called over the horizon, OTH, over the horizon radars. So right now it is just visual range or 400, 500, 1,000 kilometers. But beyond the curvature of the Earth, that OTH, how OTH will work, it will send some signal to the satellite, and that reflection will go to the target, and then it will communicate through satellites. So that latest development, what is happening in LRD is OTH radar, over the horizon radars. So for this medium power radar that is named as Arudra. All the radars in LRD is named on some of the Nakshatra, Arudra, Suni, like that. We are more inclined towards our culture and all. So this radar is a fully active phased array. I don't know, any one of you from electronics background here? We have professors from aeronauticals. Most of us are from aeronautical or mechanical background. Anyone from electronics background? Then you are from. Then you will be catching my words. It's phased array based radars. It has got electronic steering, vertical also it can scan. Same time it is rotating also. So this is being a fully active radar. All electronic components are packaged in a small cabin which is rotating all the times. So that cabin need to be for longer life. For longer life of the system, it should be moisture free. That cabin, if it is moisture free, life of any electronics component will be better. Means probability is sustainability will, reliability will increase. So for that, I designed one system that is called Antenna Pressurization System, which will fill that cabin with the dehumidified air, so that life will be more. But see, it's working as a dehumidifier, but name is written Antenna Pressurization System. Slightly confusing name. Nomenclature is slightly similar to my name. My name is Kumar Gaurab, but I am not related to the Bollywood star like that. I don't know how my name has come. My actual name was Ram Kumar, given by my father. Again, based on God name, Ram Kumar, Syam Kumar, like that. But I don't know how my name has come as a Kumar Gaurab. Maybe one of my teacher, he was impressed with some heroic work I have done. So he has put my name as Kumar Gaurab. Okay, I will move forward. So I will start with the introduction of the APS system. What is the requirement of the system, why this system is required, and then how we can extract moisture from the air. Today, do you know what is the humidity level in the air of Thiruvananthapuram? Anyone? What is the average humidity level day to day? Maybe 70 to 80, 85, sometimes 90 also during rain and all. So how we can, I'm going to explain how we can extract moisture out of the air and purify it. Then I will also talk about what was the constraint in my design, within what limit I have to design that system, then what are the critical components in it, and what I have done for better reliability of this system, then some challenges, and then I will take some case studies also. So what is the work of this system? This will take atmospheric air, like if radar is working in Thiruvananthapuram, there will be 85% humidity in the air. If we fill that air into system, reliability will go down. So what it does, it takes the air from the atmosphere and it separates the moisture out and it fills the antenna cabin with this dehumidified air. Now, why pressurization is required? That cabin is to be pressurized slightly, 20 to 30 millibar, so that external air will not enter into the system. That is that's why, just for that sake only, it is to be pressurized. As you guys are from aero background, it is just query to me that aircraft, all of you may be knowing how aircraft flies. Because of the wing profile, there is a pressure difference across the wing. Bottom has got high pressure and top has got low pressure. But I really don't know. What is the difference in pressure level from top to bottom? What is the difference? Range. Can anyone tell me? Just approximate range. It is not, I'm not asking what is, it may be range only, it may be variable. So what's the pressure? Anyone? Just guess, wild guess, if you are not knowing, just a guess. What may be the difference between pressure on the top of the fin and on the bottom of the fin? Just a guess. Tell me something, any figure. कुछ भी बोलो यार. क्या होगा, कितना होगा? Since you guys are from aero background, that's why I'm floating this question. Yes, sir. No, difference in pressure, sir. What is the difference in pressure between the down of the fin and top of the fin? Because of that, it is gliding. So what is the range of pressure, madam? कितना रहेगा लगभग approximately? मेरे दिमाग में आया कि क्या रहेगा. एक दिन while I was flying, and I was in aircraft, I was thinking what will be that pressure difference, and immediately I just tried to calculate. Then I found that it is in the range of 20 to 30 millibar also only. Means 2000 to 3000 Newton per meter square. How I did this calculation? I assume that I am flying with the aircraft that is 35,000 in weight. So multiplied by 10, that much Newton force is required. And approximately I calculated the area of the wing. What is the area of the wing? Area I know the thrust force, how much thrust it's creating. And based on that, I calculated that pressure. The pressure range was coming in this range. Maybe some variable, maybe my variable in my area calculation. I calculated the area roughly, that at the starting of the wing, it's around 5 meter, and at the tip of the wing, it's around 2 meter, and the length of the wing is around 20 meter. If I calculate, it's 80 meter square. 80 meter square one side, another side is 80 meter square. So totally is 160 meter square. If I multiply that with 2000, that is Newton per meter square, it comes to 32 ton, equivalent to that. So that way I am telling, and this is my just approximate wild guess only, rough calculation. And this query was there in my mind. And one more thing, during testing of this system, that whether my system is providing supply air at 20 to 30 millibar or not. So some flow meter I used to do it with a flow meter. So what I did, I just blown my air through that system. What I found that pressure range also, maximum, at the max, I can blow at 30 millibar and lowest 20 millibar. So that pressure difference is just equivalent to that air blow. So, and that is sufficient to lift our aircraft. Question is, what is the problem with the moisture which it can cause in the system? You guys may be knowing very well that if moisture is there, this picture shows there is a deposition of moisture on this cabin. This is, what is this? This is called cabinet of computer. Am I right? Inside there is a deposition of moisture. If such deposition is happening on any electronic system, what will happen? There will be a short circuit. Or because of moisture, capacitance also changes, because there is a difference in dielectric strength of air and water. Water has huge dielectric strength, maybe 1,000 times, around 1,000 times than air. So if there is a moisture content in the air, it will alter the capacitance of the system, and it will alter the performance. So those problems, sometimes arcing also can happen. This is also because of the moisture problem. Then mold growth. Mold is what some biological thing, formation, you might have observed on any system. If it is kept in a humid environment, some biological growth happens on the system. So these are the problems associated with the humidity. That's why this humidifier is required for that radar system. Corrosion also. And it is seen that if humidity level is between 40 to 60, rust formation is minimum. Similar to the failure rate dependent on temperature. And can anyone guess if humidity is 0%, what will happen? There will be a problem with us also. we will feel very uncomfortable. In the same way, electronic chips also, they cannot survive at 0% humidity. Pure means pure air is also not good. If humidity is less in the atmosphere, we also feel uncomfortable, and chips will churn. Moisture from that will constantly come out, and slowly it will degrade. So it is observed phenomena that if moisture level is kept from 30 to 40%, it is giving best performance to the system. So what was the requirement? I know all of you are feeling hungry. So based on the antenna cabin size, it was required that system should provide 1650 liter per hour. That was based on the size of the cabin. And then pressure requirement was just required to be above atmospheric pressure. Then humidity reduction, 20-degree dew point reduction. If we do, if it can cover up to 95% of humidity level in the air. Then this size constraint. Initially, size constraint was I had to design a system which should be half meter by half meter by half meter, a cube of half meter edge length. But it could not be done. So later that constraint was revised to 0.6 meter by 0.6 meter, and height was strictly limited because that antenna was rotating. Antenna is rotating things, and it is kept on the pallet where that is a stationary portion. So the gap between this stationary frame and that antenna was only 600 mm. So some clearance is also required. So height was strictly restricted. Apart from that, some weight constraint, because it is a mobile radar, it is on a vehicle, so weight should be less, power consumption should be less, and it should have remote communication system, so Ethernet links and all. This is the calculation. I will not go through the calculation, how this calculation has come, flow rate requirement. This figure may be clear, this system is mounted here, and this whole thing is rotating. I will be having one. Once it is transported to some site, what it will do, it will deploy itself, and then it will rotate. So what this system I have designed is kept here, and this platform is rotating, and this below this platform this height limitation was there. That's why I wanted to show this video. This is just animated video. This is not actual video. I have in fact actual video also. Can you please close it? So now I'm going to tell that how moisture can be separated from air. One thing is, if we cool the humid air, we feel that moisture gets separated. It becomes dew, and on the surface it gets deposited. So it can be separated by passing air through cold region. And based on such system, dehumidifier is called refrigeration type. And based on this system, systems are slightly bulky. Another way it can be done that it can, if I pass the air through some material which has got high affinity for moisture, it will be absorbed by that system. And such material which has got high affinity for the moisture, that is called as desiccant. And there are some well-known desiccants like silica gel and alumina and all. I will talk about it later. Another way is to filter it. If we have a micro filter, if I pressurize the air and pass it through that filter, moisture will be separated. So based on this principle, the dryers are known as membrane dryers. I will not go through this because all of us are feeling hungry. This is showing that all three process, how it will be happening. If we take the refrigeration type, what will happen? First air will be cooled to the saturation temperature, and then further cooling, this much moisture will be separated out, and then it will be reheated, and finally our outlet will be at 40% RH. And if I take the dry desiccant type, it will be happening like this. So let us not talk about that. And can anyone say what is that dew temperature? Dew point temperature? Any one of you? Suppose today there is 85% humidity in the air and temperature here is 30 degree. What will be the dew point temperature? Approximately above 30 or lower 30? Above 30 or lower 30? Lower 30. If I cool that air at maybe 27 or 26 degree, it will start condensing. So that temperature is called as dew point temperature. And that depends on how much percentage of humidity is inside that. So that is the idea of dew point temperature. So there are basically 4 types of air dryers based on different principle. If we pass it through that material which are more hygroscopic, absorbs the moisture, based on that dryers are called desiccant dryers. And here we can have dew point range, output air. Output air can have dew point minus 40 to 2 degree. And if we go for refrigerated type systems, this can give us dew point range from 0.5 and above. So we cannot have air which has got dew point below sub-zero. Sub-zero dew point we cannot have. Then another type is delicescent type. Delicescent materials are such material which after absorbing moisture, it becomes liquid. You might have observed salt. Salt, once it gets moisture, it's become liquid. Have you observed? So those materials are called delicescent material. So if I want to purify the air, what I will do, I will pass my air through that. That material will absorb that moisture, and my air will be purified. But but what is the problem in this? We need to replace. Every time we need to do quick replacement. But in my military application, we cannot have such system where we need frequent replacement. It should be working for years. After years, it should be maintained and all. And also, reduction in dew point is very less in this. Similarly, membrane type. Membrane type also dew point can have from 5 to 20 degree only. And membrane air dryers needs very high pressure. To pass through the micro pores of a filter, we need to pressurize the air at very high pressure. So those are the problems. So there are 4 types of air dryer. I will go through the details of those dryers one by one, and then I will tell you why I have selected particular type of air dryer. Do you guys are catching me, finding interesting or boring?
It's a bit slow.
Sir?
Going a bit slow.
Oh, a bit slow. how desiccant dryers works. I'm going to internal detail of the system. There will be a 2 tower filled with those desiccants. Moist air will be passed through one of the tower, and this tower will absorb the moisture. Slowly, after 1 hour, depending on the moisture content of the air, slowly what will happen, that desiccant will be saturated. It will have a limit to absorb, no? So after some time, it will be saturated. Further purification it will not do. So after some time, what we'll do, some flow control switches will pass the moist air to other tower, and this tower will be heated or passed with the low pressure air, so that will regenerate it. So there is a 2 process. One is generation and another is regeneration. Generation means removing the moisture from the air, and in regeneration we remove the moisture which is absorbed by the desiccant, so that another time it can be used. So what is happening here, this is being generated, here air is being purified, at the same time another tower is getting regenerated. Here this air is taking all the moisture from this tower by heating. So here we need not to replace the desiccant. After some time this is being regenerated and this is being generated. In this there are 3 variants. First one is called heatless desiccant air dryers. Here there is no heat. There is no heating here, but what is required is very high pressure is required. So that because of the concentration difference, moisture will flow from air to desiccant, and in the regeneration time, low pressure is passed through that desiccant, so that because of the concentration difference, moisture from desiccant to air it will pass. Another problem associated with this is we need to create very high pressure, up to 7 bar. So in order to accelerate the process of this desiccation and regeneration, some heating, if I can heat this element, so it can be accelerated, and very less pressure can work, 1 to 3 bar. And this heating can be either internally or externally. In this case, heater elements are placed inside, and it is heating that directly to desiccant. So desiccant will remove the moisture. Here what is happening, air is heated outside, and that heated air is passed through that. So in my case, what I have selected is internally heated tap to make the system very compact. So I will directly rush to the my schematic diagram of my system. So this antenna pressurization system has got 4 or 5 units. One is compressor unit that is required to compress that air, and then there is a drying unit, that is desiccant tower and all, and there is a pressure control unit. After pressurizing, we need to depressurize it and fill it to the antenna cabin. And the system has to work only when the pressure of the cabin falls below 20 millibar or the humidity level goes up. Otherwise, system has to keep silent. Its function is not continuous function. So for that, we need some control. So we have field sensor system which will sense the pressure of the cabin and moisture level. And then in order to do it automatically, there is a programmable logic controller which controls all these operations. So these are the internal details. We have 2 towers desiccant tower 1 and desiccant tower 2, and air is pressurized by compressor 1 and 2. There are two compressors. Actually, one compressor can work, but for increased reliability of the system, one redundant compressor has been used. Wherever there is a chances of failure, like solenoid valves, which are electromechanical system, chances of failure are more. So there we have provided redundant components. Full redundancy was not possible because of the space constraint. So what we have humidity sensor in the inlet also. At the outlet, we have solenoid valves. We have one tank to store that air. Then we have two compressors. Then we have multiple solenoid valves. And of course, we have air filters. Apart from that, we have field sensor systems and PLC systems. I will not go through the major components, how I have selected components and all. These are the heaters required to heat that desiccants. I will directly show the realized system. These are various desiccants. Silica gel, alumina, and molecular sieves. These are widely used. So, what is the mechanism in desiccation? This hygroscopic material, which are called desiccants, those have electronegative bond at the top, and all of us know hydrogen bond formation, how it happens. So on the surface of this desiccant, hydrogen is trapped by hydrogen bond. This moisture content, which is H2O, that sticks to that surface with hydrogen bond during generation phase. Moisture from the air sticks to the surface, and moisture-free air pass out. And once we heat this H2O goes back, regeneration time. These are the comparative study of various desiccant, and which desiccant I have selected is the one which can absorb moisture, most of the moisture. Means silica gel has got two good property, that it can absorb up to 40% of its weight, and at the same time it has got poor retention capacity at elevated temperature. That is good for me. If I heat it slightly, it will remove all the moisture. So regeneration, it will be better. That's why silica gel has been selected for the purpose of that. So for the reliability requirement of the system, we have two compressors. One is redundant. Actually, one compressor is enough to work, but one will be in the standby. If one goes bad, another will take over automatically. Then we have used oil-free compressor, that we need not to oiling it, so that years together it can work without maintenance. And desiccant air dryer has been used, so that we can regenerate the air itself, need not to. Then all sensors and regulators has been chosen to be mill grade, and there is a redundancy and solenoid valve, which is a very active component. And challenges was packaging everything in a small box, and then selection of component, and then how to route all those systems, then safety and qualifications. It has gone through environmental qualification as well as EMIFC qualifications. And these are some of the case studies which has been observed that this system is very much required. If this system is not there, these are the problems has happened. In conclusion, what I can say is that this system has been designed for a mobile radar. It can be used for similar such radar also, anywhere. Thank you so much for any question.